Why are winters colder with global warming? Burning fossil fuels has heated the planet by 2 degrees. The decade from 2010 to 2019 was the hottest on record. This has brought extreme winter weather. Colder winters are linked to the warming of the Arctic. Arctic temperatures rise faster than the global average. They shrink the ice in the Barents and Kara Seas. As a result, snowfall over Siberia increases. This impacts the swirling winds above the North Pole. The polar jet stream dips deeply southward. It brings cold Arctic air to warmer areas. Severe winter weather swept into the US in January 2024. It broke temperature records from Montana to Texas. In 2021, a cold wave disrupted the Texas electric grid. It was associated with a stretch of polar vortex. The polar vortex is a stream of air around the North Pole. The vortex is closely connected to the jet stream. It's a band of strong winds about 6 miles above the ground. Increasing temperature disrupts the polar vortex. It can distort the jet stream and push it southward. The jet stream determines the winter weather in Europe. When it's strong, it flows from west to east. It holds the cold air from the Arctic. It brings mild, windy, and rainy weather from the Atlantic. If it's weak and wavy, the polar vortex also weakens. It sometimes breaks down completely. It has caused a collapse of the polar vortex. Arctic warming is particularly strong in winter. The wind stream begins to fray. It leads to more dips that affect temperatures in Europe. Warming over the subtropics also affects the jet stream. The Arctic warming directs the jet stream southwards. It causes cold spells in Europe. The subtropical warming sends the band northwards. In this case, the winter weather in Europe is milder. Snow forms when warm, moist air meets very cold air. In 2021, Germany saw 30 inches of snow. There's an area of high-pressure air called Gisela. It brought cold Arctic winds to the center of Germany. There, it collided with 2 low-pressure areas. They are called Tristan and Reinhard. These areas carry warm sea air. Rising temperatures mean more water in the air masses. So warmer air holds more moisture. This moisture can then become snow. There were massive snowfalls in the Alps in 2019. They were triggered by unusually moist and warm air masses. The oceans were still quite warm due to the hot summer, so a lot of water evaporated. The air currents then took it to the Alps. An enormous amount of wet snow fell at high altitudes. The changing jet stream also affects summer temperatures. There are more meandering jet streams in summer. These meanders tend to remain more stationary, so the heat can last for an unusually long time in summer.